Okay, let's talk about my solar battery and talk about the components that are here. Up on the top, I have a fusible switch that will let me kill the power that is coming off of my charge controller and going to the battery. So I can kill the power to that. I also have an inverter that is 800 watts and it's good for 2.1 amps is the output at 5 volt. So that's if I use the USB output on it. Otherwise, we would just take the voltage, 120 volts, and we would divide it by 800, and that's going to give us about 6 amps. My batteries, I made a configuration change. My charge controller is relatively inexpensive. It's like $26, but it will do up to a 40 volt input, but I have to change my battery output charging for the charge controller. I have to change it to 24 volts. That will allow me to bring in the higher voltage. Now, I made a decision here to go ahead and do that, even though at 24 volt with my 35 amps, that's going to give me about 1.5 amps at 24 volt. I'm going to reconvert that 24 volt after the battery is charged and go through a regulator to bring it back to 12 volts so I don't have to change my inverter. So that's going to then end up doubling, so I'll have about little over 3 amps of power that I'll be able to use. This inverter is going to give me 6 amps that I could draw on it. So I shouldn't be maxing out the inverter. My batteries shouldn't be just sucked dry right away because I'm supplying a lower current and I plan on drawing a lower current. So this is going to be an inverter or a solar charger for smaller loads, the type of thing where if I have solar panels that are helping to keep it charged, I could run a little refrigerator and some lights off of it without a problem. If I'm just going to run it by itself with no solar backup, I might want to use this for something like charging all of our cell phones in an emergency, charging tablets, maybe running the internet router and modem, those type of loads. This is not something that's going to run my whole house. I only have two 35 amp hour 12 volt batteries in here. But with solar backup, I want the higher voltage, which is going to allow me to charge these batteries quicker. So that's the decision I made, is that during the day, I'm going to be able to draw full amount off of this inverter because the power is going into the battery and I can draw right back off it. So I'm getting a boost from the solar panels on top of the current that I'll be able to draw from my batteries directly. So this is what it looks like outside. Let me just point out where everything goes. Currently, these cables here, they go and tie onto the battery, onto the positive and negative posts. This is a jack that I have that takes the MC2 connectors that come off solar panels and have my positive and negative. Those go into the case and then they come back out a hole up here, and then I routed them in to the solar panel input. Out of the battery output to charge, I came out, and one of them is just going to go right into this lug. Even though it's going into the inverter, theoretically it's connected to the same post that I want to go to inside the case, so I'm just landing it here. The other one, instead of landing directly here, it lands through my switch and my fuse protection. Now, I'm not going to be drawing that much current through here, but I have wire that's number 10 that's rated at 30 amps. And once again, I'm protecting the wire. I want to make sure that if anything's going to happen that would make these things go over 30 amp or it might start to melt down, I'm protecting it. Otherwise, it acts just as a switch. I can simply push the button and that turns it off. Those are relatively inexpensive. I think I got a pair of them for $8. So pretty inexpensive altogether, and a rather sort of a simple way of putting a solar generator together. Let me open up the case now, and we'll show you inside. So inside I have 2 batteries. Each battery is the same ones that we've been working with in the class. I put a real thick neoprene tube in between here. This will prevent those terminals from ever touching each other. I'll probably going to put some heat shrink on this also. But as it is right now, once this thing closes in, those batteries are stuck. So here, this is coming off from our inverter and goes onto the battery. The other one here would land onto the positive side. I've got it off right now while I'm showing you this and working on it. I have jumpered the battery together, and you can see I'm jumpering the positive terminal to the negative, which is giving me 24 volts. But 24 volts at 35 amps, because I'm using both batteries at the same time to get that 24 volt, and each battery is good for 35 amps. It gives me, like I said, about 1.5 amps. But then I'm going to re-regulate it back after it comes off the charge controller or the batteries. I'm going to re-regulate into the inverter back to 12 volts. I could buy a 24 volt inverter, but it's more expensive, and I bought that regulator for, I don't know, $8 or $9. And it's a 30 amp regulator, so it's more current than I'm going to be able to draw off these batteries. So that's pretty much it. Right here is where it comes in off the solar panel connection, and I have it coming through the case here and back out one hole that I created that everything traverses in and out of. So that's it. I mean, a pretty simple install. And you should, if you were to be given a question about this, or maybe a picture, you should be able to identify the different things that we're looking at. So, once again, if I look here, positive terminal, the black wire goes to my inverter. This negative loops up and over and goes to the positive terminal goes to the negative. That puts these batteries in series. So now this becomes my positive terminal. And between here and here, I have 24 volts because I'm reading through this, through here, and here, and they are additive. Since I'm getting my 24 volts by using the 12 volt of each battery at the same time, my current will deplete the same time. So my current actually stays the same of the one battery, because I don't get twice the current. I'm getting twice the voltage. Now that I have twice the voltage, I can charge it much quicker because I'll be charging at 24 volts as opposed to 12, but I'll have a higher current than I would at 12 volts. My current's going to be higher, which means it'll charge faster. And that's what I'm looking at, is to see that these charge faster and I can draw off them faster. Then I'm going to be coming back off the battery, and ahead of where I put the regulator, I will tie in my output to my charge controller. So I'm still charging at 24 volt, but then I'm going to tie into the regulator, and before I go in to my inverter, I'm going to change it back to 12 volts. When I do that, I will get twice the current, because now I'm going back to 12 volts and I'll have about a little over 3 amps. And that's going to be perfectly fine for what I need for a portable power pack here. This is something I could take on a job site, hook a drill motor to, if I didn't have power somewhere. I could bring it out to a party and run a radio and some other stuff for the whole day. Should be more than fine to do that kind of stuff. If I had solar panels that were backing it up, I'd be able to do even more things and be able to run that all day. So this is my little solar generator kit.